Hello friends, this is Navijit Bhattacharya. You are watching Math Domain. आज मैं आप लोगों के साथ थियोरी ऑफ कॉन्ग्रुएंस के बारे में डिस्कशन करूंगा। थियोरी ऑफ कॉन्ग्रुएंस एक इम्पॉर्टेंट टॉपिक है जो बहुत सारे फील्ड्स में यूज़ होता है, लाइक ग्रुप थ्योरी। ग्रुप थ्योरी में इसका यूज़ है टू डिफाइन कॉसेट एंड अदर्स थिंग्स। और फिर थ्योरी ऑफ कॉन्ग्रुएंस आपके नंबर थ्योरी में यूज़ होता है। डिफरेंट पार्ट्स ऑफ नंबर थ्योरी जो फॉर्मेट थ्योरम है उसमें, फॉर्मेट लिटिल थ्योरम उसमें, और भी है बहुत कुछ। तो डायफेंटाइन इक्वेशन उसके सॉल्यूशन में यूज़ होता है। तो देयर आर डिफरेंट पार्ट्स ऑफ मैथमेटिक्स जहाँ पे थ्योरी ऑफ कॉन्ग्रुएंस का यूज़ होता है। सिंपल कंसेप्ट है, इजी कंसेप्ट है, बट यू हैव टू अंडरस्टैंड things. So because of that I am making this video on theory of congruence, and the notes or the slides that I'm going to use here I'll put in the description box. You will find that you download those notes. You can use it for your study purpose directly, because I have written in such a way in simplified form and easy to understand. So just watch my video completely, watch the complete video so that you will understand what I have written in the notes. Okay, okay, so let me start. Okay, fine. So theory of congruence, the definition is, let a and b be two integers. Means if a and b are two integers and n is a positive integer greater than 1, I have taken. You can take greater or equal to 1 also, no problem in that, because for n equal to 1 it is quite obvious. Then we say a is congruent to b. Important, this line, a is congruent to b modulo n. A is congruent to b modulo n if a minus b is divisible by n, and in that case we write this in this form: a, then equivalent, this equivalent sign, a equivalent means here we say that a congruent b mod n. Okay, and another definition that we use is, if a and b, these two definitions are equivalent, though I have not proved it in this video, but these are equivalent. A and b are two integers and n greater than 1 be a positive integer, then we say a is congruent to b modulo n if there exists an integer q such that a can be expressed as a equal to b plus nq. If there exists some integer q such that you can write a is equal to b plus nq, then we can say that a is congruent to b mod n. So these two definitions are equivalent, means one can be replaced by other. Here the divisibility that I have mentioned in the definition 1 is divisible by n. Divisible means a minus b is divisible by n, means the remainder when a divides b is 0, means it will completely divide a minus b. Okay, so come to the properties of congruence. Here I have just given basic properties of congruence. I have not gone through the theorems. In the coming videos I will discuss theorem also. The properties of congruence are: a is, any integer is congruent to itself, because you can easily see a minus a is always 0. So a minus b is divisible by n. So a minus a is always 0, and 0 is divisible by any n. So because of that, a is congruent to a mod n. It is very easy. Now the second property: if a congruent to b mod n, then b is also congruent to a mod n. So this is a symmetric property of congruence. So let a congruent to b mod n, then by definition a minus b is divisible by n. Therefore if a minus b is divisible by n, then you can write that b minus a is also divisible by n. Okay, this is quite clear, because if 4 minus 1 is divisible by 3, then 1 minus 4 is also divisible by 3. So because of that, b minus a is divisible by n. It follows that b is congruent to a mod n. Now property 3, if a is congruent to b mod n and b is congruent to c mod n, then a congruent to c mod n. It means this is a transitive property, means if a is congruent to b and b is congruent to c, then a is also congruent to c. The proof is easy, because a congruent to b mod n and b congruent to c mod n, it means a minus b and b minus c both are divisible by n. Now two numbers are divisible by n, it means, sorry, if you add those two numbers, their summation also divisible by n. Now if I add, then a minus b plus b minus c is divisible by n, but a minus b plus b minus c is nothing but a minus c. It means a minus c is divisible by a minus c is divisible by n. It means this a minus b, c divisible by n, n means a is congruent to c mod n. Okay. So now the next property, if a is congruent to b mod n, then for any integer c, a plus c is congruent to b plus c mod n. This is also an easy proof. You can easily prove this property. Let a congruent to b mod n, it means a minus b is divisible by n. Therefore, I can write a minus b as a plus c minus b. Now, a minus b is divisible by n means this expression is also divisible by n. I can rewrite this expression in this form, that a plus c minus b plus c is divisible by n. This, from here I can write a plus c is congruent to b plus c mod n. Okay. Hope this is simple for you. Now if a congruent to b mod n and c congruent to d mod n, then a plus c congruent to b plus d mod n. This is also an easy proof. This is similar to the last one. A congruent to b mod n and c congruent to d mod n. It means a minus b plus c minus d both are divisible by n. If two numbers are divisible by n, then their product is also then their summation is also divisible by n, as I have told you earlier. It means a minus b plus c minus d is divisible by n, but this expression is equal to a plus c minus b plus d. It means a plus c is congruent to b plus d mod n. Now for the next property, if a is congruent to b mod n and c is congruent to d mod n, then ac congruent to bd mod n. To prove this, I use the second definition. Okay, second definition of the congruent. You can prove those previous proofs. All of them you can prove using the second definition also. And for me, the second definition is quite helpful, because it has a particular expression of a, means a is equal to b plus nq, means you can use this thing again and again. So it is quite easy for me, but as this is the first time for you, so I am using definition 1, because definition 1 in every book, the congruence, the definition of congruence is same as the definition 1. Because of that, I am using definition 1 to prove these properties. But for this one, I need definition 2. Now let a congruent to b mod n and c congruent to d mod n, means I can write a is equal to b plus nq, and similarly c can be written as d plus np for some integer p and q. Okay, p and q are any two integers for which this a equal to b plus nq and c equal to d plus np satisfies. Therefore, what is the AC? AC is nothing but product of these two numbers. Now if I write this or if I distribute this bracket, then I can find BD plus, you can see I can take n common from rest of the terms, so I can easily write BD plus NR, where R is some integer which is equal to this. It means AC is equal to BD plus NR. It means AC is congruent to BD mod n by the definition 2. So this is quite simple, because I cannot use that particular definition 1. It's difficult to arrange but if I use definition 2, it is quite simple. And even the last proofs also, if I use definition 2, it become more simple. You can use definition 2. Okay, the last property is, if A congruent to B mod n, then for every positive integer k greater than 0, A to the power k congruent to B to the power k mod n. Okay, so this is for every positive integer k, means I have to use induction here. So I'll prove the result for induction. For k equal to 1, it is quite obvious because it is given A congruent to B mod n. So assuming the result is true for k minus 1, therefore A to the power k minus 1 is congruent to B to the power k minus 1 mod n. Okay. Applying the property of congruence, we have A. Here I have used this property, this property. Sorry, I am shooting in my home, so there are sounds. Forgive me for that. Okay, now A congruent to B mod n and C congruent to D mod n, then AC congruent to BD mod n. This property I will use here because A congruent to B mod n and A to the power k minus 1 congruent to B to the power k minus 1 mod n. It means A into A to the power k minus 1 is congruent to B into B to the power k minus 1 mod n. It follows that A to the power k is congruent to B to the power k mod n, and this result is true for integer k. Hence, by induction, it is established that the result holds for every positive integer k. These are the properties of congruence. I haven't proved any result using the congruence in my next video on congruence, because my next video may not be on congruence, but on congruence, when I make another video, I will solve some problem and show you how to use congruence in this direction. Okay. Okay, so this is how we prove we can, sorry, what I sorry once this is the these are the properties of congruence. In this video I have just this video is for to show you what are the properties of congruence. Because of that I have made this video. In the next video on congruence, I will solve few problems using congruence and give few results on congruence, few theorems. But important part is the problem part. I will show you how to use congruence in finding reminders of few numbers when you divide one number with other. If you divide, say, number 5, sorry, if you divide 2 to the power 100 divided by, say, 5, 6, 7, whatever it is, then what is the remainder, or whether it divides or not. How to use congruence to find this is very, using congruence, it is very easy to find those things. So I will show you how to use those, how to use the theory of congruence, the properties of congruence to prove or to find those things. Okay, till then, goodbye.